Hi, this video clip explains some applications for two-variable inequalities, and we'll be graphing two-variable inequalities. Here's an application. Let's say you have $12 and you take some friends to McDonald's to eat. There are 6 people. A cheeseburger costs $1 and a McFlurry costs $2. An inequality might be written something like this for what you can do with your $12. We'll ignore tax. The number of cheeseburgers, we'll say that's C, and times $1, so we'll just say C, plus $2 for every McFlurry, M will represent the number of McFlurries, needs to be less than or equal to 12. So C plus 2M is less than or equal to 12. If we rewrite that kind of more like y equals mx plus b, we might be able to graph that better. So let's get the C all by itself. Let's subtract 2m from each side. So C is less than or equal to, let's write the negative 2m first. Like we do with mx plus b, we usually write the x coefficient first. That 12 is positive, so we'll say plus 12. But maybe we ought to review graphing real quickly, and then we'll show you how to graph this one. So let's say we had y equals 2x plus 3. The y-intercept is 3. The slope is 2, up 2 over 1. And then we would connect that with a straight line tool, solid line. Something like that. Well, back to this inequality. C, we'll have the c-axis, and we have an intercept of 12, so I'm going to have each square represent 3, and then for the number of McFlurries, each square will represent 1. So the y-intercept on that would be 12. The slope is negative 2. So down 2 to 10 and over 1. Down 2 to 8 and over 1. Oops. That'll be more like that, closer to 9. Down 2 from 8 would be 6 and over 1. Down 2 from 6 would be 4. Down 2 from that would be 2. More like that. And down 2 from that would be 0. But this one is not, doesn't say equals, it says less than or equal to, because it could be equal to $12 because we're going to ignore tax. Let's go ahead and use a straight line tool that's solid, but let's not go into the negative regions of either cheeseburgers or McFlurries. We'll just go in the positive region, and it says less than. So, well, 9 cheeseburgers is less than 12. So we know we need to shade below the line. So we're going to shade everything below that. I'm going to stay in the positive region just because we're talking about money and cheeseburgers and all that. So we're not going to go into the negative region. So any of those combinations, any of those points would work for what money we have. For example, 6 cheeseburgers and 2 McFlurries. That would be $6 for the cheeseburgers, $4 for 2 McFlurries. 6 plus 4 is 10. 10 is less than 12, so that combination would work. We could get a cheeseburger for each person and 2 McFlurries, and maybe get some cups and split it. Or we could just get 12 cheeseburgers and each person could have 2. Or we could get 6 McFlurries and each person could just have a McFlurry and no cheeseburgers. All kinds of combinations in there would work. If we only got 3 cheeseburgers, we could get 3 McFlurries. We could actually even get 4. We could go to 4 McFlurries. And back there on that 6 cheeseburgers, we could go clear to 3 McFlurries because that is right on the line, and we decided that we were going to forget about tax, and so we could go right to $12. Well, that's a specific one. What if we had just some generic inequality that we needed to graph? First of all, we want to get the y all by itself because we are used to graphing y equals mx plus b. So let's subtract the 4x from each side. So 2y is greater than 8 minus 4x. Let's divide each side by 2. So y is greater than 4 minus 2x. Let's write the 2x first, the negative 2x, and then the 4. The inequality sign still stays the same, greater than. So we have a y-intercept of 4. 1, 2, 3, 4. Slope of negative 2, down 2 over 1, down 2 over 1. Now this one doesn't have a story on it. We don't know where that equation came from, so we don't know about any limits. So that equation could keep going. However, we're not going to graph it with a solid line because it does not say equals negative 2x plus 4, y equals negative 2x plus 4. It says y is greater than. So I'm going to use a dotted line just as a reference point, and then everything greater than that. Well, right on the y-axis, 5 is greater than 4, for example. So we're going to shade everything on that side of the line, of the dotted line. So that's how you would graph that inequality. That shading indicates any of those points out there would work. Let's try another one. Dividing each side by 6. Well, x divided by 6 is the same as 1/6 of x, 1/6 times x. We could write the x term first, if that helps us see our y-intercept better. Our y-intercept is 1. Our y-intercept is 2. And our slope is down 1 over 6. Now, that is not a solid line because it does not say less than or equal to, it just says less than. So I'm going to grab a dotted line, straight line tool. Let's try. That wasn't so great either. There, something like that. It says y is less than. Well, right on the y-axis, 1 is less than 2. So we know we're going to be shading below that line. The dotted line means that line is not included, but just everything below there. Let's try one where the inequality sign flips around. We want to get the y all by itself, so let's add 3x. Let's divide by negative 6. So y Dividing by a negative, the inequality flips around, so it says y is greater than or equal to 12 apples divided among 6 people, each person gets 2. Positive divided by a negative is negative. 3 apples divided by among 6 people, each person gets 1/2 of an apple. Positive divided by negative is negative. Let's rewrite that with the x term first, just so it's easier to find our y-intercept. Our y-intercept is -2. Let's have each square be 1. Go down, start out at -2. Slope of down 1 over 2. Now this time it says y is greater than or equal to, so we can use a solid line. And we don't know any boundaries. Oops, we want a solid line. We don't know any boundaries for that equation. We don't know what story it came from, what problem it solves, but so in general it would look something like that. Y is greater than, well 0 is greater than -2, for example. So we know we need to include that point, so we need to include everything on that side of the line, above the line.